There are two kinds of byte orderings. Okay, there are two types of byte orderings: big-endian and little-endian. Okay, fine. The byte ordering basically depends on the machine architecture which you are using. It doesn't even depend on the OS, and it depends on your machine architecture. Okay, Java is a machine. When we say Java virtual machine, it's a machine. And so even the byte ordering is fixed for that machine. Okay, you know about these two byte orderings, big-endian, little-endian, for numeric types, especially for numeric types which use more than one byte. So you can think of short, fine, leave that byte, it's single byte, doesn't matter. Short, int, long, float and double, right? Okay, let me take an example of, let's say, int. I have an int value. So if I have an int value and that int value is stored at location 100, let's say. I store int value at location 100, it takes 4 bytes, right? So it will have memory locations 100, 101, 102 and 103. Fine, these are the memory locations occupying. Now the value which I have stored is 75, let's say. I put 75 in that. So it will have 3 bytes which will be 0 and 1 byte would have 75. You don't need more than 1 byte for storing 75. That means your most significant bits are zeros and your least significant 8 bits would have the value of 75. So there are first 3 bytes which are zeros and last byte is 75. Okay, tell me, where are the zeros in memory locations? Which memory locations have zeros and which memory location has 75? First, second and third, 100, 101, 102 should have zeros, and that's what is big-endian. Fine, yeah, 75 should be here. This is big-endian. The machines which you are using, which one? You are using Intel, x86 architecture, x64 architecture, right? You are not using mainframe or those other machines, RISC architecture, no, that's not being used. Fine, they follow big-endian, but the machines which you are following, they use little-endian. What is little-endian? The little-endian, their logic is, we have least significant byte at a lower memory location. Get the point? That's other logic. So 75 is here, 0, 0, 0, 0, 0, 0. That's what is little-endian. So there are two kinds of byte ordering. Java follows big-endian. Java uses big-endian. Fine, byte ordering is important. It's important to understand about the byte ordering, and especially if you are working with some network based protocols, fine, the sender and the receiver, are they following the same byte ordering? Fine, that's important. Fine, when you talk of files, okay, I look at JPEG file or GIF file, they have a header, right? In the header they'll say, okay, oh, we have byte position this to this, holding the length of how many pixels wide, okay, but that uses maybe it uses 2 bytes or 4 bytes maybe. Fine, in 4 byte there's a 4 byte allocated for it, but then you should know what order. Is it following the big-endian or the little-endian? Fine, whenever we have more than 1 byte values, okay, fine, any type which is more than 1 byte, you should be always knowing what is the byte order. Fine, you create a file, a binary file, fine, on your Intel machine using C code, same C code used for reading on another machine, it's non-Intel, fine, a RISC machine, it will read the values completely wrong. Fine. Because the byte order is different. When you say read that int value, it's a 4 byte value. Okay, fine, I'll read that 4 byte. But how to interpret them? Okay, so byte order. Java uses big-endian. Okay. Fine. But anyway, there are in Java library you have mechanisms for, if you know that I have to change the byte order, they can easily be changed. Fine. Even while reading from a file, you know the byte order is different. Fine, make it little-endian. Yes, I can read little-endian also.